Welcome, everyone. Good morning, good afternoon, or good evening from whichever part of the world you may be joining us. Welcome to the Marine API Community Tech Talks, which are nothing but the sessions that we build for all of you members of the community for Apigee and application integration. So let's get things started. This community is initially intended for all practitioners and people interested on all things APIs and integrations for Google Cloud. Let it be the purpose of Apigee and application integration and its other intertwined with different Google Cloud products. So you will have these sessions at your disposition so that we can continue to empower you and share knowledge and best practices across these new technologies and new advancements that we have each and every day. So welcome if you're new to these sessions. It's really great to have you here joining us. The simple rules of these tech talks is we're always going to be having a Google presenting topic to you. In this case, we're going to be having Maria, which she is returning to this scenario. It's really good to have you again, Maria. At the end, you can have a Q&A section so you can ask your questions, give your ideas with the Google experts you're having in this space for you. We're going to be meeting almost every Thursday, so keep an eye out there for upcoming sessions. I'll give you the link so that you can sign up for the upcoming sessions we'll have for November and December. And as you can see, this session is being recorded, and we will make sure we share the recording with you in case you have to drop off or you want to watch the recap of the session once again. You'll be able to find the recording in the Google Developer Program Forums community or in our YouTube channel for the Marine API community. Last but not least, I always like to make this invitation to everyone. If you'd like to join the scenario and share a presentation or just by yourself with the community on some of your expert knowledge you would like to share with the rest of us, you will always be more than welcome. You can reach out either via the community or via LinkedIn, whichever way you want to. You always will be welcome to present at this stage. With that, I'm not sure if I covered this, Maria, but do you want to have questions throughout the session or at the very end?
Both is totally fine. So if there is any
Perfect.
question, just let us know. Yeah,
Perfect. That's
anytime is good.
okay, everyone. So you can either use the chat or raise your hands, and then when time allows, we'll give you the permission so you can open your mic and pop your question. With that, as you know, Maria will be our speaker for today. She is a customer engineer for the Apigee and application integration team. She has been here before presenting really great presentations to us. So today she will be walking us through the AI-powered testing, the complete API test automation with Apigee API Hub and GCP. So welcome everyone, and thank you so much, Maria. So take it over.
Thanks a lot, Alex. And I'm here today with Tyler, who has also presented a great demo to show. So, and thank you everyone for being here today. So, hi everyone. So let's start now with the Red-Green-Refactor cycle, and this is the core loop of the test-driven development. It's ensuring robust, clean, and maintainable code. So let's start with Red. This stands for writing a failing test. Here we start by defining new functionality or maybe a desired improvement with a small test that initially fails. This establishes this requirement. Then we have the green part. This stands for making the test passing. Here we write the absolute minimum amount of production code needed in order to satisfy the failing test and make it pass. So focus purely on the functionality here. That's the main part. And then we have the refactoring, the refactor, which stands for improving the code. With the safety net of passing tests, clean up and optimize both the test and production code without altering its behavior. So this step enhances the code quality, readability, and also the maintainability. We're starting here with the general framework, and of course, we will go over to Apigee. Now, while the test-driven development gained widespread recognition with all the agile methodologies in the late 90s, its core principle or its roots of the test-first coding is far older. And this is going back to the foundational days of computing. In the 50s and 60s, early programmers working with mainframes adopted a deliberate approach. They wanted carefully to define the expected output or behavior of a program without even having written the code, so before even writing the code. And this practice was related to modern TDD and ensured that development was guided by clear and predefined goals. So we knew exactly what we wanted as a result. And this methodology was even documented in programming books, also in 1957 by Dr. Meg Cracken. And this historical context reveals that the value of defining expectations upfront has long been a recognized discipline in software development. And precisely this test-first approach forced early pioneers into careful incremental development, breaking down complex problems and defining successful outcome for every small piece before even implementing it. And this methodical construction, rather than a big bang approach, having everything from the beginning all together, this aimed to define the done before coding even began. So laying the conceptual groundwork, so what is needed to be done for the TDD practices that we continue also to refine today, because this is something, a living product that is being shaped all the time. So moving now forward from those historical roots to with the test first concept in mind, and this experienced a significant increase in formalization in the late 90s and also in 2000. And this was largely driven by the Agile movement. And this period represents the rediscovery of these powerful ideas, giving us test-driven development as we understand it today, as we know it today. And the central figure in this rediscovery was Kent Beck. Kent is one of the contributors of the Agile Manifesto and also a pioneer of extreme programming. He didn't invent the idea of testing first, as we have seen before. It existed already, but he re-articulated it. He formalized it into a repeatable discipline and also popularized it in a way that truly resonated for all the developers. He recognized its immense value for managing complexity, improving the design, ensuring quality, making also the cornerstone practice with extreme programming. In extreme programming practices like pair programming, continuous integration, TDD, all work together to create a highly disciplined and incremental development. So Kent Beck essentially gave a name and a clear process to what had previously been more informal, if you wish, more intuitive, also a sporadic practice in the end. And the real game changer for TDD's widespread adoption was Kent Beck's seminal book. So he published the test-driven development by example. If you're interested in TDD, if this is something you're looking to, this book still is highly recommended. It's not just a theoretical text where you have it in theory. It literally walks you through building functionality using the TDD approach and demonstrating the concept step by step. And this book clearly articulated the now famous Red-Green-Refactor cycle that we have seen in the very first slide, which is providing a simple yet very strong framework that new generations of developers could easily grasp and apply. And it moved TDD from an abstract concept to a practical, actionable daily coding habit. And in the end, this places a fundamental practice in modern software development. So a significant debate now in 2014, because if we're talking about TDD, we cannot leave this page of the history aside. And this debate started in 2014 by David Heinemeier Hansson. This is the creator of the Ruby on Rails framework, and he challenged the test-driven development with a provocative post back then that TDD is dead, long-lived testing. Hansson's critique here wasn't against testing itself, which is he strongly supports, of course. It was rather against the strict, unwavering adherence to the test-first TDC cycle in all scenarios. He argued that TDD, especially in complex system development, could lead to the test-included design damage, where the focus on easily unit testable components might result in overall granular or inflexible designs, so prioritizing individual testability over all the system coherence. So Hansson's further criticized issues like the brittle test suites, minor code refactors would break numerous tests due to tight coupling with implementation details, and making testing in the end a burden. And he also highlighted excessive mocking, which could lead to tests validating mocks rather than the actual integrated system's behavior. And this important debate ultimately encouraged the TDD community to reflect on these practices, clarifying the contexts where TDD is most effective and prompting a more nonsense discussion about how and when to apply TDD strategically rather than simply whether to apply it. So following now the critiques of the TDD behavior-driven development emerged as a significant evolution primarily developed by Dan North back in 2006. BDD addresses common TDD challenges, such as developers struggling with test naming and focusing on implementation details rather than meaningful system behaviors. It acts as an enhancement to TDD, providing a clear framework for defining requirements and shaping tests around the fundamental question, what behavior are we trying here to achieve? So a core strength of BDD is emphasizing on shared language, so moving beyond technical jargon to describe desired system behaviors, business outcomes in an understandable way for all the stakeholders. BDD utilizes natural language tools and syntax like jerking with keywords such as given for the context, when for the actions, and then for the outcome to facilitate clear communication and ensure alignment among product owners, quality assurance people, developers, and all the stakeholders needed. And it's more than just a testing technique. So BDD is a collaborative team methodology that promotes an outside-in development approach. So starting with defining external user behavior, BDD ensures that software truly meets user needs and also delivers the business value that it aims. So bridging in the end communication gaps and fostering better understanding between the technical and non-technical teams. So if you're familiar with Apigee here, we have also a tool called Apigee. Apigee is built on top of a popular testing framework, Cucumber, and it supports behavior-driven development. So this goes also in the direction of Apigee here. Now, in our era in 2025, the practice of test-driven development is characterized by pragmatism rather than the strict dogma. So moving beyond a universal test-first approach for every line of code. TDD's enduring legacy is the normalization of automated unit testing, which is now a fundamental expectation in professional development. High-performing teams typically employ a flexible blend of strategies, so TDD for complex new features or critical business logic, test after for simpler code or even mocking prototyping, and BDD principles for defining features and acceptance criteria with non-technical stakeholders. The focus has also shifted from achieving 100% code coverage to writing valuable tests that protect key behaviors and enable confident refactoring. This pragmatic approach provides a safety net for improving code structure without introducing regressions, a key long-term benefit, of course, of TDD. So the results include, of course, a significant reduction in defect density, so often 40 to 90%, as you see here, leading to higher quality software, fewer production bugs, happier users, and reduced maintenance costs. So underscoring here that modern TDD is about smart, effective testing in order to support continuous delivery. Good. The widespread adoption and effectiveness now of TDD and the automated testing are significantly strengthened by the rich ecosystem of developer tools. They're now available across various programming languages and, of course, across every platform. For Java, JUnit remains the industry standard for unit testing, offering flexible annotations, assertions, integration with IDEs, and builds systems to streamline test creation. In Python, PyTest has become the de facto choice for providing a more modern and less verbose alternative to the built-in unit test modules. PyTest is a highly popular and effective tool for Python developers, so largely due to its clear code, robust features, and the range of plugins that it is offering. In the JavaScript ecosystem, particularly for Node.js and front-end development, Jest holds a strong position, especially favored for React projects. It's known for its all-inclusive design, offering complete testing solutions with integrated test runners, assertion library, and mocking features. More recently, VTest has gained traction by offering Jest compatibility with enhanced speed, leveraging Vite's native ES module support. And this robust tooling landscape across many languages ensures that developers can easily integrate TDD and automated testing in their daily workflows, regardless of the specific technology stack they're on, and fostering high-quality development without the need to struggle for testing solutions. So Having explored now the history and the evolution of TDD, including the debates, current pragmatic applications, next significant advancement lies in the AI-assisted TDD. So artificial intelligence is increasingly enhancing the entire TDD loop with tools now capable of drafting initial successful unit tests based on production code or requirements. And this capability helps developers quickly generate successful behavior tests, significantly reducing initial load and boilerplate, and allowing them also to enter the red state faster from the cycle while reserving human expertise for complex business logic and also edge cases. Beyond the simple test generation, AI is proving very important in identifying overlooked scenarios by suggesting edge cases, by mutation scenarios through code analysis, and it can also automate the generation of code mutations and propose new tests to cover them. So this is dramatically improving the test suite robustness. And furthermore, in the refactor phase, so the third phase that we have seen of the cycle, AI tools assist also by identifying complex code, potential duplication, proposing some cleaner implementations, and all this with a safety net of existing tests. And the ultimate aim is to empower developers here by handling by handling all the cycle, allowing them to focus on design, critical thinking, the architectural decision, and fostering also a collaborative environment where human intelligence is augmented by AI for accelerated execution, for coverage, and also in the end for enhanced software quality and delivery. Let's get now more concrete towards Apigee, so TDD within Apigee. So we were discussing the slide today with my colleague Tyler, and we love the slide because everything comes together here. So the pyramid illustrates how test-driven development, API testing, contract testing build upon each other. And the broad-based unit testing and TDD are sitting, and they're using tools like V-Test, Mocha, and they establish a strong foundation by ensuring individual code components are robust and bug-free. This inside-out approach, where tests are written before the code, guarantees the internal structure and functionality of your services are robust and well-organized. So providing quick feedback and isolating issues very early and easy. Moving up, the integration BDD layer focuses on ensuring these well-tested units work together seamlessly, so often with tools like Apigee, verifying the flow and interaction between different parts of the system. Finally, we have contract and comprehensive API testing, utilizing tools such as Hurl, Postman, or even Specmantic to provide external validation. This top layer guarantees that your API is not only functioning correctly, but it also adheres to some predefined contracts, meeting the expectations of its consumers in the end. And thus, TDD fundamentally underpins the entire pyramid, creating testable APIs that can be confidently integrated and reliably presented to the outside world via the strong contracts. So as we know them today, over API portals, over the Apigee portals, or over API Hub. More concrete now, so in the context of Apigee, a platform for developing and managing APIs, the test-driven development offers an approach to build robust and reliable and maintainable API proxies and integrations to other systems. The TDD process begins by defining the requirements first, which in Apigee translate to establishing a clear API contract, specifying desired error handling mechanisms, those strategies, outlining security measures, for example, authentication or authorization, and setting performance expectation. With these requirements in hand, the next step is to write tests for the API behavior. So what should the proxy do under various conditions? And this is something we need to answer. And this involves, of course, creating automated tests for individual API proxy components and overall API flows, covering expected successful responses, various error scenarios, edge cases, security policy enforcements before any proxy configuration or code is even written. And this test would verify, for example, that a specific policy within Apigee correctly applies a rate limit, or that the JavaScript callout policy is performing the piece of task that it should do and transforms the payload in the end, for example. And once the tests are written, the developer's focus is to shift and to implement the proxy logic to pass tests. So concentrating on addressing the failing tests at a time. And this means configuring policies, developing callouts in Python, Java, JavaScript, and setting up conditional flows within the Apigee proxy environment with the purpose of making the currently failing tests pass. And this iterative small-step approach ensures that each piece of the API logic behaves precisely as expected, and addressing all the requirements like authentication, rate limiting, data transformation that we have been talking about, or even routing in order to fulfill exactly the requirements and meet the end goal in the end. And finally, with all the tests passing, the process moves to the refined proxy configuration where developers optimize and clean up policies and flows without breaking any existing tests. And this refactoring stage is supported by TDD safety net and allows also for continuous improvement of the API proxies design, preventing from messy configurations and from any break that could break in the end the functionality. And this TDD cycle provides immediate feedback, helping to confirm the correct execution of all the Apigee policies and the integrity of the data flow, which are critical for an API gateway to manage a complex API ecosystem. So now, why TDD for Apigee? Adopting the test-driven development within an Apigee context offers compelling benefits, primarily by directly addressing the inherent complexity of API proxies. Apigee proxies often involve intricate policies, data transformations, service orchestration tasks, and TDD forces developers to create tests for each component before implementation, ensuring every piece of API logic from authentication to routing and data manipulation performs exactly as it's intended to do. And this granular validation is crucial for building robust and predictable API behaviors. So we need to confirm that complex proxy configurations are sound from the outset. Beyond initial development, TDD's automated test suite acts as a vital safety net. It prevents regressions by providing immediate feedback on any modifications or refactoring of existing proxies. This enables confident changes, ensuring API stability and reducing bug introduction. TDD also instills a discipline of defending clear requirements upfront, translating explicit API contracts, having error handling in place, security as also performance expectations into concrete tests before any proxy is even configured. And this leads to focused incremental development and allows for continuous refinement of proxy configurations, resulting in high reliability, maintainability, and in the end, adaptable Apigee APIs. And in this journey, also API Hub, of course, assists us. We will explore Apigee API Hub, which is more about the discovery, the governance, and can actually play a crucial role in enabling and strengthening the TDD practices across an entire API ecosystem. API Hub acts as our single source of truth for all the APIs that are existing within a company and their specifications. This is incredibly powerful for TDD. Remember, our first step in TDD is to define requirements first. So API Hub allows us to centralize those requirements by publishing our open API specification, our Swagger specifications, our API specification in the end. And this means every team building or consuming an API knows exactly what the contract is upfront. It's not just documentation, it's the agreed upon blueprint that dictates the behavior. With those contracts in API Hub, we can now truly embrace test-first design. Instead of guessing, developers can confidently write their automated tests based on directly what is published in the open API specifications within API Hub. And this ensures that our TDD efforts are not just building functional code, but code that strictly adheres to the approved API designs within a company and anti-enterprise governance standard that is defined within API Hub. And it reduces ambiguity and ensures compliance from day one. APIs are rarely then static, they evolve, we know that. They are living products, I would say. API Hub supports this evolution by allowing us to manage and version our API specification. And this is critical for TDD because it means our development teams can write and run tests against a specific version of an API contract. If an API is undergoing a major revision, we can test against both the current and the new revision specification, ensuring in this way backward compatibility or smooth migration. It gives us a stable, traceable reference point for all our test development. Before we even get to coding or testing, API Hub significantly enhances collaboration. It provides a centralized space for all the stakeholders, so product owners, quality assurance people, architects, developers, to review and agree on an API behavior. When the design in API Hub is clear, it directly translates into more precise and comprehensive TDD test cases. Less guesswork in design means less rework in testing and development. And finally, by housing not just specifications, but also comprehensive API documentation and design guidelines, API Hub guides consistency. This consistency is vital for TDD as it ensures that test creation follows established patterns and best practices across organizations. It helps us propagate effective TDD practices, making sure that regardless of which team builds an API proxy, they're all working towards the same high standard of quality, informed by a shared understanding from API Hub. So that's in a nutshell what I had to present today. Are there any questions before we go to the demo?
Thank you, Maria. We do have one question from Akash. I'm going to read that for you. Which category contracts test will fall into, and how are they different than integration tests?
So you see here the parameter, right? So you see that we have the unit test as a base here, and then we have the component test and acceptance test. This is here where also the contract testing would take place, right? In these two steps here.
Yeah, and
just
to jump in, I think contract testing is always just with the contract, right? So just with the API, with the open API spec or the GraphQL schema, right? So it's not testing anything behind the scenes, but just what the contract user can access and can see. So I think that's normally kind of where people start with API testing, right? Is that, okay, we're going to have APIs, they're all going to have open API specs or, spec of some kind, and we can do a lot of contract testing on those specs, right? I think where I've seen, and that's kind of some of the background for the session today, was that, often our APIs have a lot more detailed logic behind the scenes, right? Where TDD and unit testing could be very helpful, right? To help, just measure the quality of proxies. And that's something I'll get to in the demo in just a moment. But yeah, any other questions before we jump right in?
Some more questions in the chat. I guess we're ready.
Cool. Then I will share my screen now. Yes, exactly. Yeah, so I'm just going to start with that pyramid again because I like this so much. This is where we're often looking at how to test which layers of the platform, right? And Apigee is really BDD, behavior-driven acceptance tests. As mentioned, the contract testing is based on the API specification. And then unit testing, which is detailed, right? Every little individual unit of the functionality is something we want to test with unit test or TDD. So let me jump into a demo of something I've been exploring in this topic of how to do unit testing or detailed functional or feature testing within Apigee proxies. So TDD approaches in Apigee. Apigee proxies can have lots of logic, right? They can have quite a lot of decisions, can have scripting, different policies, conditions, right? That have very different effects on how the processing works and how the integration with backend services functions, right? So this is something I've been looking at in more detail. Okay, how can we test proxies or also features within proxies in a detailed way, and including assertions of any internal variables, right? Because to do unit tests, we need to be able to test, any runtime data that is being processed, so any variable basically at runtime, as well, of course, as traffic metadata or traffic data, which is something we would also test from the contract testing side. So I have some source code that I just published that does an example of this. I've called it upstream test. It's very new. If anyone is interested or wants to look into it or collaborate on it, just reach out. And I'll be publishing a forum post in the Apigee developer forum probably this or next week. So with that, let me jump over to a proxy. So this is a proxy that has, so just for the target endpoint, it is just proxying our Apigee mock target. But it does have a couple of additional policies in place to do testing, right? So this is something I've been looking at, is to have some standardized policies that can apply unit testing within proxies if a proxy is deployed to be tested, right? So this is never something you would put into production or deploy into standard proxies, but if this is, in a test environment and we want to unit test this proxy, these are some additional policies that we can put in. The first question that I had is, how do we get our test cases, or how do we evaluate the assertions, right? So basically what I did is I built a little external repository that, let me go back to the architecture diagram, that basically runs in Cloud Run, where I can manage kind of the assertions and the different test cases that I want to test in the proxies. This is quite nice because this basically independent of the proxy deployment. So I can iterate, add test cases, rerun the tests, right, all in real time without having to redeploy the proxy. The policies in the proxy are static. They're always the same. They basically just take the test cases from the external service, apply them at runtime in the proxy flows, and then pass the results back out, right? Running tests can just be done through, the same Perl or any other test, Postman or any other test framework you want to use. The only addition is that we're doing assertions locally within proxy policies, right? So let me jump back over to my proxy and let me start a debug session so we can see what's going on. And basically how this works is that, okay, so now I have my debug session ready. Let me fire a request here at my endpoint. So this is my Apigee endpoint. The base URL is feature tester v1, and I'm calling the Git path. And I'm passing here, and I call it an upstream, kind of a test ID, right? This is basically just an identifier that's going to go to my test server, retrieve the test cases that are then applied at runtime in the proxy, right? So now this is running against the mock target. You see that there is no /git on our mock target, so it returned to 404. You see here we have some extra headers, so X upstream data, and these are basically the assertions that were tested in that flow, right? So it was testing some headers, status code, some JSON path properties from the response payload, and the result was there were 4 tests. One passed and 3 failed. What happened in the proxy processing is that those test cases basically in a preflow are retrieved here in a policy. If we look into the variables, we basically retrieve that header, that upstream test ID, and write the test cases as a variable, basically the assertions that we want to test, right? So in this case, first name is John, city is San Jose, some headers and some status codes. So basically those are written into variables. Then in the post flow and default flow, just running those tests at the end of processing, right? So in this case, here we see that, okay, running those tests and writing also as headers the variables, the values that were found for all of those assertions, generating a test result.
Hey, Tyler,
Yeah, sure.
I think they're saying they cannot see the proxy screen.
Oh, I'm sorry. Yeah, no, now I'm sharing the right tab. Sorry, yeah, apologies.
Okay, thank you.
Yeah, exactly. And in the case, maybe just to recap, here within the proxy flow, at the first thing in the pre-flow is just to evaluate that test ID, the upstream ID, to use that to get the test cases from the test server. So basically, all of our assertions that we want to test. So doing some JSON path tests of payloads, some headers, status code tests, and then in the post flow as well as in the default vault flow, then running those tests, right? To say that, okay, let's run through them, writing a test report back to the test server with all the results. So what was the actual result of those assertions that we wanted to test? Also writing them into headers that someone could check as well on the outside if they wanted to in a test tool, right? You could evaluate them in Postman or in Hurl script, and then those are saved to the test server. So this is basically just a way of evaluating assertions at runtime in the proxies. This test server is, I just published it here on GitHub, so it's just a Node.js, simple Node.js service that you can easily push tests to, define tests just by pushing into the server, for example, just with a list of assertions, and then running the policies that are in the example proxy, and then the results will automatically be pushed back to the server as well, right? So let's take a look at the results on the server side. So this is deployed in Cloud Run. And so all of the results data we can also visualize just by passing our test ID to the URL, and just having a list of all of the runs, right? So this is just an HTML page that takes the JSON text result document that we generated in the proxy and visualizes it. So if we do a refresh and we see that we just ran this run at 4:33, and the only assertion that was correct was that the header X powered by Apigee was still set, but everything else failed, right? So just like Maria was describing, this is really fitting the TDD approach, or just a robust test approach. Is just having very detailed tests, within our internal, in this case, API proxy logic, right? And this is something we can just monitor as a traffic light, right? The runs that failed with every new release, the runs that passed, and having very detailed checks. The thing that I was really looking at was especially having tests of internal variables in Apigee. This is, of course, one of the super powerful things of Apigee proxies, is that I always have those internal runtime variables that are storing runtime data. And if we use those for logic, to make decisions, often we're using them for conditions. That's something that's really useful to really, keep under observation, right? And have test cases on those internal variables, so that if something does change, you can, see it immediately, right? So let's go back to the console. And since we're calling our Apigee mock target, there is a JSON method that we can reach. So let's go ahead and call that. I'm calling it with my same test ID here. So now you can see that the upstream test results were 4 tests, 4 passed, 0 failed. And those properties were all correctly evaluated. If we jump back over to the test console and do a refresh, you see, okay, our latest run, all of these variables are correct. So the JSON path from the response, the first name is John, city is San Jose, the response header was always correct and is still correct, and the status code this time is 200, which is that's what we're expecting, right? So this is kind of looking at ways to apply TDD principles and robust, detailed unit tests within proxies, having a way to just have assertions flexibly defined that we can monitor, right? I would be super, super interested if anyone has experience or ideas or approaches that have worked in the past to accomplish this goal as well. So I think if anyone has some good concepts or examples or structures they've used in the past that have worked well, then I would be super interested to hear about those. And maybe we could have some good forum posts on different approaches to TDD in Apigee. The next step, of course, is to, bring these test results into API Hub, as Maria mentioned. That's something we are still, building out the capabilities of API Hub in this area. I mean, I think basically it would be possible to define, a custom attribute to hold the test results. As far as I understand it, the custom attributes in API Hub, I think altogether the data can be 10 megabytes or many megabytes, right? So I think there's enough, we could also run collections like for, per version, have test results here as well. Unfortunately, there'd be no pass-fail visualization like in my other little dashboard, but you could link to that dashboard, for example, from API Hub as well. So basically collect the test results for the versions here and then have a link out to the dashboard with the detailed test results. So that would be something in the next step that I would be adding. Yeah, so basically the only difference though, I think, is that API Hub, will have the complete APIs. And what I'm kind of working on is, testing very small feature API, like pieces of API, basically. So if we think about microservices, do one small piece of functionality, with robust tests to very much validate that functionality. What I also often do with API proxies is have, individual shared flows or small proxies that do one thing very well, right, with all the variables and the processing for that. And then using the TDD unit tests, very intensely on that, specific kind of, feature proxy or subflow or, shared flow, basically, right? So I don't know if those things really, I guess they could also be an API Hub for sure, even though I don't think that's the, the primary purpose of API Hub is collecting small, feature proxies. Maybe it is, but in any case, at the moment, I see API Hub more as for like the, the actual released APIs, right? But those could have tests as well and test results.
Hey, Tyler.
Mhm.
I got a question. Do we have a lab for this?
No, not yet, but that would be something I would also really like to work on. So when I post the forum post on this topic, so keep an eye out for that, then we could put this into a lab very easily as well, for sure. Yeah. Cool. And that's about it. If you would like to try this out yourself, there's a link in the presentation to this repository. This is all really, really new. So I just pushed this today. It's been testing this first version with having flexible assertion, functionality for Apigee variables, as well as, all the request response, basically any piece of runtime data you can fetch and test in the assertions, right? So anything, basically we do just a flexible get variable request on any piece of data, and then either do an equals or a contains on that data. And all of that gets logs to the headers as well as to the test results. And so that's the current first version, right? I'm sure there's tons of cool stuff that could be added, but that's like the basics to apply, detailed test assertions within proxies. Yes, so the links are in the presentation, which were shared. Also from this session, the recording and the presentation are always shared on the RSVP site, so it's all there. And if you're interested in digging deeper, happy to synchronize, with any special ideas or requirements you have, because this is something I think it will be really useful going forward to add TDD to Apigee proxies, and then future next step, get that into API Hub, the results as well. Cool. Any questions on these topics? Or does anyone have any recommendations or approaches that they would like to recommend to the group? Then yeah, I think that's about it then. Yeah, I'll go back to the slides.
Thank you. Let me do some wrapping up of the session. Thank you, Tyler. So, like Tyler's sharing, please share your feedback. It's always really important that you give us your thoughts and the way you feel the sessions went. So as you can see here in the meeting that you are, you can either look at the top right corner or in your meeting options to select the poll and then cast your vote in there. But if you'd like to share more detailed feedback or even share some thoughts on some upcoming topics you would like to see for these community sessions, I'm pasting right now in the chat forms so you can dive deeper into the feedback you can share with us. That'll be, again, it's really valuable for us so that we can pivot these ideas with you and improve the sessions as we move forward. Can we go to the next slide, please, Tyler? Thank you. So, Tyler, yourself here, why don't you tell us a bit more about the upcoming session you have next week for the community?
Yeah. So we're always looking at better together sessions with other Google Cloud services. Of course, Cloud Run is one of the most popular services on GCP. It's just every customer I work with, everyone's a huge fan of Cloud Run. So we're looking at some ways of using Apigee together with Cloud Run in innovative ways, right? So combining server APIs and serverless, it could also connect into this testing topic as well, but we'll see. But this will be a deep dive on, Cloud Run and APIs with Apigee and Cloud Run. Yes, Paulo, I see your comment on Apigee and Kubernetes. Actually, that could be something we touch on as well. So the Apigee Kubernetes operator is now, it's been GA for a while, but we also added hybrid support to that as well. So that could be something we can touch on as well, because that is, of course, the future of how we're using Apigee together with Kubernetes and in a very integrated, cloud native way as well, for sure. And I see another comment from Zhao. We also use something similar like snapshot testing, but we have the assertions on Apigee. Yeah, awesome. The issue with Apigee that I had is that, like that's more of the higher level, right? So either contract testing or BDD testing. So you're really, testing the request or the response data, right? So you can't get at that internal, assertions for runtime variables. And so that's kind of what I was looking at, getting into the more detailed unit and TDD tests, just because, if I'm doing, some very specific logic, I would like to validate that as well, with internal assertions, right? So. And then Paulo, I see, I meant using Kubernetes to host our APIs instead of Cloud Run or mini Cloud Run. Okay, great. Yeah, thanks for the suggestion. We'll definitely keep that in mind. And then Varun also mentioned, love to hear about Apigee adapter for Envoy. Yes, that's another great topic for sure. So I think that fits as well into this overall cloud native approach with APIs. So look at bringing those topics into the session. Yeah, that would be great.
Awesome. Thank you, Tyler. So I do have another couple of upcoming sessions that I want to share with you. It's going to be a different format. As you can see, we're going to be having two experts joining us in this session, Matt Harman and Almi Tahuri. They will be hosting this session respectively on November the 20th and December the 4th, answering live your forum questions. So if you have popped one of your questions in the Apigee or in the Integration Services Forum, you have a chance that some of these questions may be handpicked by these experts to give live answers to these common questions you may be having. So stay tuned for these sessions. It's going to be really exciting. These won't be our typical 1 hour long webinar. It'll be just 30 minutes as we go through a few of these questions from the forum. So in the link I pinged in the chat, you can register for these sessions. Make sure you do that so that you can get the joining link in advance and all the details so that you know which questions they will be giving answers to. And yeah, that's for the upcoming sessions we have for now. If we can go to the next one, please, Tyler. As usual, I always like to invite everyone to join our community spaces. We have dedicated forums and knowledge hub for Apigee and application integrations, respectively. You can scan the QR codes, or I'm as well pinging in the chat to you the links so you can go to the Apigee community. Over there, you will see a section for events, and that's where you're also going to be able to find the recording and the deck that we're going to share for the presentation of today. And with that, this is it that I have for the updates and wrapping up for the session. Anything else you would like to add? More? Any questions or comments? Other suggestions for topics? I guess we're all good to go then. Alrighty, everyone. Well, thank you so much, both of you, Tyler and Maria, for the great presentation. I'll make sure I'll get all of these assets shared with the community, and we see you next week so that we can see Tyler's presentation.
Great. Thanks, everyone.
Thank you all very much.
Bye-bye.
Have a
Thank you,
nice
Tyler.
day.
Thank you.
Namaste.